are continuing to work with rational exponents. All right, right now this is not in rational exponent form, this is in radical form. We're going to take this, we're going to change it to what's called a rational exponent. So what we're going to do is, this number 4 is called your index. I'll label that the index. Okay? Something you should know at this point is if I have a radical, and I have the letter n represents the number in the index, and I have another number raised to the power of n, that's changed to a rational exponent by doing base a to the power of n divided by n. So right now we're just going to do each individual one. So right now I'm going to do 3 different colors. I'm going to do a 36. I'm going to do an a to the power of 8, and then I'm going to do b to the power of 5, 3 different colors. Now I'm going to put a 1 right there. So we'll start out. We'll do 36 power of 1/4, just to start out. This one we're going to do a to the power of, that's not very good, of 8 divided by 4. And then we're going to do b to the power of 5 divided by 4. Yes, this index is even, so we do have to beware. We might have to put absolute value bars around one of these answers. We'll figure out which one that's going to be. At this point, I want you to change the number 36 to a more simplified version of 6 squared. We're going to raise that to the power of 1/4. Now right here is called a power of a power. And with the power of a power, you're allowed to multiply. And 2 times a 4 is 1/2. That's about as simple as you can get it right now. All right. By the way, just so you know, we're keeping this as a rational exponent. Yes, 6 to the 1/2 is a radical 6, but we're not going to write a radical 6. But radical 6 is the same as 6 to the power of 1/2. This one's the easiest one, because 8 divided by 4 is 2, so it's just going to be a squared. So I'm going to leave it as a squared. Do I need to put absolute value bars around this one? No, I don't, because that's an even amount right here, not an odd. Now, the last one, we really can't simplify b to the 5 over 4. But this is what you have to ask yourself. How many times does 4 go into 5? Does it go into it an even number of times or an odd number of times? It goes into it once, right? Odd. So because 4 goes into 5 an odd number of times, you have to place absolute value bars around the letter B. This right here is your final answer as a rational, using rational exponents. Now, what would this answer look like in radical form? If you simplified it in radical form, let me show you what your answer would be if it was in radical form. You would have a squared, right? A squared would be on the outside. Okay? By the way, I'm going to do this real quick. 4, that's b to the 5th, right? But you have a one group of 4 inside. So yes, a b would come out. What did we say you had to have around here? You had to have absolute value bars. And then you have a radical. And what's going to be inside the radical? A 6. Right? And, hold on a second. Well, if we use the 4. Hold on a second. If we use the 4, unfortunately we have to keep it the 36. If there's a 4 there, we'd have to keep the 36 the way it is. Okay? And then you have a b right there. So in radical form, this would be your answer in radical form, because you can't really reduce that. Remember, that's 6 squared. But this would be your simplified answer in radical form. This is your simplified answer as a rational exponent. What we're going to do next, everybody, is we're going to take all of these right here, this one, this one, this one, and so forth, and we're going to change all of these and change them into radical form, not rational exponent. All right, before we go ahead and change things from rational exponent form to radical form, we're going to do another problem here. Now, you'll notice real quick that this right here is the number 5. That's our index. The index always goes in the denominator when you're making rational exponents. So this is 27 to the first. So if I wanted to change this radical to a rational exponent form, I'm going to put a 1 over a 5. So it's 1 over 5. It's going to be x to the power of, we're going to put 10 over 5. And then y to the power of 5 over 5. You're going to notice that this index will always be the number in the denominator every single time. Now, some of these can be quickly simplified, all right? We're just going to keep 27 to the 1/5 right now. But you can pretty much see that 10 divided by 5, that's going to give you an x squared. And 5 divided by 5 will give you a 1, but I'm not going to write a 1 there because I don't need to. You could put 1 there, they won't mark it wrong. If they do, they're just really neat. This would be your final answer. Notice there's no absolute value bars anywhere because that's an odd index. An odd index, you don't have to worry about placing absolute value bars around any of your variables. So right here, that could be your final answer. Now there is an alternate answer. And the alternate answer goes when you change 27 to another version called 3 to the power of 3. If you have 3 to the power of 3, hopefully whoever's watching this video, you realize that 27 is also 3 cubed. If you take this 1/5 right here, you do a power of a power, that's the same as 3 to the 3/5. So an alternate form of this answer could be 3 to the power of 3/5 times x squared y. Either one of these answers will suffice for the correct answer. Most simplified. We're going to do one more problem. We're going to do just a basic one, problem number 13. I realize we're going backwards. This right here is the number 2. That lets you know you have what's called an even index. Okay? So right now, what's going to be in our denominator every single time? A 2. So we're going to write x to the 5 over 2, y to the 6 over 2. And that's why I put the 2 right there in the denominator. Now one of these can be simplified a little bit more. That's the 6 divided by 2. It's just 3. Y cubed x to the 5 over 2. Now, one of these, you're going to need some absolute value bars. You're going to need absolute value bars around the y because that exponent is odd and you have an even index. Now, you don't need it around the x. If you're wondering, why don't you need it? That number 5 is odd. Why don't I need it around the x? Because 2 goes into 5 twice. It goes into it an even number of times, not an odd number of times. Now, this may not make much sense, so watch what I'm going to do. I'm going to simplify this using radicals, not rational exponents. If you have x to the 5th, and you have y to 5, 6. There. Y to the 6th. Square roots look for groups of 2. So this right here, in radical form, you'd have a what? You'd have an x squared. You'd have a y cubed, and what would you still have left inside the radical? 1x. Does that require absolute value bars? No, because it went into it an even number of times. That's why I don't put absolute value bars around this, but I do have to put absolute value bars around the y. All right, that's enough dealing with that. We're going to go ahead and go down here, and we're going to do a slightly more difficult problem. Ooh, I like this one. Right now, we're going to do problem number 20. All right, number 17. I need to make sure that we change this not to the simplified radical. All right. Yeah, we did. All right, but we simplify as a radical, not a rational exponent. Okay. So right now, what we're going to do, we're going to simply say that's a 2. Okay. Just so you guys know, to make this nice and easy, this is 2 to the power of 10, and we have a to the power of 3 all inside of a radical. This is 2 to the power of 10 over 2, and a to the power of 3 over 2. Because once again, we're placing this index in the denominator. 2 to the 5th is still 32. But our final answer for the rational exponent is going to be a to the power of 3 over 2. But we have to put absolute value bars around the a. And why do we have to place absolute value bars around the a? Because 2 goes into 3 an odd number of times. And that is your final answer. The first time I did the problem, I did not do it in rational exponent form. I did this. I did 32, a, radical, a with the absolute value bars. This is the correct answer. If it was in the form of a radical, this is the correct answer as a rational exponent. Sorry about that. Thank you. It's nice to be for you. Now, number 20. This time I'm not going to make mistakes. It's express each using what? Using radicals. Now, what is our index going to be? 2. Very good. So the very first thing I want you to do is make a nice, beautiful radical symbol. Now, if you feel like it, you can put a 2 there. If you don't feel like it, you don't have to put a 2 there, because every time you write a radical, if there's no number right there, what do you automatically know it to be? 2. So right now we have 2 to the first. We have a cubed, and you have b to the power of 5. But just for the people who are watching the video, I'm just going to put a 2 there, even though you don't have to. Now, square roots or radicals, look for groups of 2. Is there a group of 2 right there?
No.
No, there is not. That's an a times an a times an a. So guess what? We do have a pair. So what comes out? 1a comes out. And then this one is b times b times b times b. And 5 of them. I have 2 pairs, right? So what comes out? A b and another what? So right on the outside of the radical, we have an a times a b squared. And on the inside of the radical, what are you left with? You're left with a 2, an a, and an ab left over. Now this is the point where you have to ask yourself, self, am I finished, or is there one more thing I need to do? One more thing. Tell me, Alyssa, what do I need to do? That's right. If you didn't hear that, she said around the a, because that's an odd, and this index is even. And that will be your final answer. Not as a rational exponent, but as a radical. All right, we're going to continue on, just doing a couple more problems, just to kind of reinforce the concept. What is the index going to be in problem 21? 3. So watch this. Right here, I'm going to put a radical. I'm going to put the beautiful number 3, which is a magic number right there. Okay. And then I'm going to put in s squared, a t to the first, just pretend like I'm writing along, and then a b squared. Now, if this index is a 3, I need groups of what? Do I have one? Here? Here? You're done. So sometimes they're easy, right? Sometimes they're easy because you don't have enough for anything to come out of the radical. All right? So on this one, it was a little bit more difficult because things could what? Certain ones could come out. This one, nothing came out. All right? Final one we're going to do. Problem number 24. Now, this right here is a power.
Power of
Power of a power, people. You gotta multiply. Help me out of this. Here we go. X to the, I like how you didn't just call out the answer. Very good. Some people would say, that's x cubed. So good job just saying 6 over 2. What's the next one?
Y.
That's right. Y, 3 over 2. Ooh, I like it. I like it because, look, what is, I'm going to change colors here. What's our index? 2. So right now, we're going to put a radical. And if you really want to, you could put the number 2 there, but you don't have to if you don't feel like it. All right? So right now, I'm going to put x to the power of 6, y to the power of 3, and z to the power of 3. So far, so good? Got a 6, a 3, and a 3. Wrote them down. Now, 2 goes into 6 how many times? 3 times. So that's another way you can simplify it. Okay? Now, does 2 go into a 3? Well, just once. We have 1 time. So basically, if you broke it down, this right here would be a y times a y times a y. So you only have what? You only have 1 pair, so only 1 y comes out. And the same concept happens for the z. 2 goes into 3 only 1 time. So, what do you still have left inside? You have 1 y and you have 1 z. Now, interesting. I'm going to write this. Here we go. We have an x cubed, right? We have a y to the first, we have a z to the first, and inside the radical we have a y and a z. Notice, all the x's came out, because how many pairs do you have inside here? You have 3 pairs. Alright, do we need any absolute value bars? Where? X, y, and z. So we're going to get it individually around x, individually around y, and individually around z. And that right there is your final answer in the form of a radical. All right, now it's time to solve problem number 27. How we solve the problem number 27 is going to how you're going to solve problem 25, 26. Oh my gosh, we're already 2 minutes and 30 seconds over our usual time. We better hurry. We have to solve for x. What would be your very first step?
Get out of that. Or take away the 1.
Ooh, yeah, but 1/8 is being multiplied to that. You can divide by 1/8, but I like. That's it. The reciprocal. Multiply this side by 8, multiply this side by 8. So here's what you have. You've got a radical x power 5 equals 3.5 times 8, which is 28. Now, it's kind of fun. Let's change this. Even though you can't see it, there's 2 there. Let's change this to a rational exponent. Change this to a rational exponent. What's my index? My index is a 2. What's going to go on top? A 5. So this is going to be x to the power of 5 over 2 equals the number 28. I'm just going to put 28 to the power of 1. To solve for x, all you have to do, here's the final step. Multiply both numbers in the exponential realm by the reciprocal 5 over 2. And right now, x will be whatever 28 raised to the power of 2/5 is approximately equal to. What'd you get, Miranda? 3.8. So 3.79. Now, I'm going to do this in the calculator. We're going to show you how it works.